Greetings and welcome to Week 3, Unit 3 on Skill Enhancement courses. In the previous unit, we understood the nature of open electives. In this unit, we'll try to understand the nature of skill enhancement courses. You may ask why skill enhancement courses when they were not there in the earlier curricula. In the context of the National Education Policy 2020 and the choice-based credit system used in Indian engineering programs, skill enhancement course is a specific category of subjects designed to provide value-based and or skill-based knowledge to improve the employability. So the main aim of skill enhancement courses is to significantly enhance the employability of all the graduates. While most of the core engineering courses or science courses focus on foundational knowledge, the SEC, that is the skill enhancement course, they focus heavily on application and procedural knowledge. For example, SGCs are the most direct way to attain outcomes like PO9, that is communication, and PO5, modern tool usage. These courses allow students to create tangible artifacts where they can see and feel and make them operate. That is, they code, build prototypes, or create reports that can show to recruit, and the graduates can show to the recruiters during the internships. That is a proof of what they have learned. It is just not merely a grade, but something, physical objects also can be shown to the recruiters. And as they are building, they participate in these courses, they are building something and they provide what you call success opportunities. When something works, when they built in their own hands, and that too something relevant, they often have higher student engagement than the traditional theoretical subjects because they're actually building and they see how they operate. It can give a what we call excellent feeling to the students that they are able to build something, and that gives them a phenomenal satisfaction. These courses can be offered as 1:0:1 or 1:0:2 courses. What are the key characteristics of skill enhancement courses? First thing is hands-on and practical focus. Unlike theory courses that may be lecture-based, SEC is a laboratory-heavy or project-based. The primary goal is for students to do rather than just know. And these courses bridge the industry-academia gap because they're solving some problem and producing tangible output which they can demonstrate to the potential employers. That means that truly bridges the gap between industry and academia. And they're targeted and specific. An SEC covers a narrow, high-demand skill such as Python for data analytics, PCB design, 3D printing, AWS cloud practitioner, and so on. And they also provide professional skills like technical writing, intellectual property rights, digital marketing for engineers, and so on. So they're very tangible skills that they can acquire through these subjects. For example, the assessment in an SEC is usually based on finished product or demonstrated skill, but not on a written examination. That is what the faculty will have to be prepared for. In the sense, you are not giving them a written examination at all. You are giving them a problem and ask them to solve, and they demonstrate that like Example is in a mobile app development, the assessment is not written exam but a working application on a smartphone. To what extent they're able to demonstrate on a smartphone will be the basis for giving them the marks or the grade. Okay. Now, let us look at some. I will not elaborate on each one of these courses, but in civil engineering, you can have a course on Revit and building information modeling, mastery of 3D modeling and integrated project data management. Revit is more like a advanced AutoCAD, and people can master that. They don't have to learn all the theory behind that. They can actually model something very specific and to demonstrate that their ability to use the software. Drone surveying and GIS mapping using UAVs for topographical mapping and processing data, ArcGIS. I'm sure if you have a course like this, all students will be quite excited to learn how to do the surveying by drones. Modern non-destructive testing, that is also one of the methods. Hands-on use of ultrasonic and rebound hammer tools to evaluate structural health. Quantity surveying and cost estimation. It is a software based using the tools like MS Project and our specialized software for professional bidding. Because anytime you bid for a project, civil engineering project, you have to find out the quantities of various things and then estimate the cost. And that is part and parcel of any civil engineer's job. So they will know how to go about using this software for professional bidding. Then another course is Green Building Rating System. That is, how do you actually rate a building as a green building? Practical application of sustainable design criteria for Indian climatic conditions. They can learn that this is a tool that can certainly be used. These are somewhat specific to civil engineering. And let us look at electrical and electronics engineering, solar PV system design and installation, PLC and SCADA programming, and hands-on industrial automation logic for controlling motors and manufacturing lines, because this is also now is very common to use a SCADA system. Electrical vehicle powertrain fundamentals, that is testing and assembling battery management systems and motor controllers in an electric vehicle. Electrical building services, designing internal electrification, earthing and lightning protection for high-rise buildings. That's a great experience one can get. Energy auditing and management, using power quality analyzers to conduct industrial energy audits. This also is a very usable skill that an electrical engineer can get. And in the area of electronics and communication engineering, advanced PCB design, embedded Linux and Raspberry Pi, that is interfacing to microprocessors and microcontrollers, FPGA prototyping with Verilog. This is a common skill that every electronic engineer would require. Antenna design and simulation, TinyML, machine learning on microcontrollers, deploying ultra low power AI models on sensors, that is Cortex M series processors. Mechanical engineering, the courses can be CNC programming and CAM operations, additive manufacturing, that is 3D printing, robotic process automation, computational fluid dynamics, smart manufacturing and industry 4.0. This Industry 4.0, it requires interfacing industrial sensors with cloud dashboards for real-time monitoring. Okay. It is like this. Every department of mechanical engineering may or may not have all the required resources. But these are some examples of courses that can be offered in mechanical engineering. Depending on the department's interest and their resources, they can pick courses from here. And we'll also show some courses which can be common across all branches. Now, computer science and engineering, obviously there will be endless number of courses in this. Full stack web development, cyber security and ethical hacking, cloud native development, natural language processing with LLMs, mobile app development. One can make a big list of these courses because it's currently of great interest to computer science students, and this is a skill that they would require whatever kind of job they go to. Now, there are some courses that can be offered in any branch of engineering. It has nothing to do with specific branch. These include digital audio visual production engineering, data management tools for business and education, AI skills for professional engineers, workflow automation using AI, data analytics. This is irrespective of the branch. Having these skills will be useful in whatever type of job that the graduate is likely to be involved in. We'll spend a little time about each one of these courses, and let us look at some sample SECs. Digital audio visual production and engineering. This can be offered 1:0:1 or 1:0:2. In fact, all courses can be offered like that. Why we are offering the choice between the two is that because practically all colleges will have to really understand how to conduct these courses, and that will take some time. Until then, they can be offered as 1:0:2. And once the infrastructure and your method of assigning problems, identifying problems, and then evaluating is standardized within a department, then it can be converted back to 1:0:1. That way you gain some courses. Okay. Now, some course outcomes for this. These are some samples. They don't have to be exactly like this. You start here and modify. If you think that 8 is too many, you can cut down. Or if you want to modify something, the people who are experienced in this area, if they suggest something, you can modify that and redesign the course. This course provides hands-on training in the technical and creative aspects of digital media. I'm sure this will interest every student, especially if it is offered in the first year. It covers the physics of transducers, that is microphones and cameras, the principles of digital sampling, multi-track audio editing, and nonlinear video editing. Students will learn to use modern tools to create high-quality technical and promotional content. The project can be to create a high-quality technical content or a promotional content for something. For your own college, for your own department, you can create a promotional content as well. Course outcomes include explain the technical specifications of audiovisual hardware, sensors, bit depth, sample rates, and their impact on signal quality. That is a basic theory that every student should know. Select appropriate microphone polar patterns and lighting setups based on acoustic and environmental situational factors. You can do that. You may want to record something outside in the field, sometimes in a semi-controlled environment or completely controlled environment. So situational factors will differ. For each situation, the student should be able to select the appropriate microphone and lighting setups as well. Capture high fidelity audio and video sequences using professional recording techniques to minimize signal to noise ratio. Edit multi-track audio projects by applying equalization, compression, and noise reduction algorithms. Here, you're going to use the algorithms. You're not going into the theory of them, how they have been derived, how they've come up. Those can be learnt in the later courses on signal processing. Okay. Further, execute nonlinear video editing, including color grading, transitions, and synchronized multicam cuts. Integrate audio and video assets into a cohesive technical demonstration video that meets industry export standards. So you need to understand what are the standards, and you have to convert whatever you create into to meet these standards. Collaborate in a production team to manage a project timeline for the say we start to the final gold version. How can you say we start means how can you fast start with the project, create something and keep improving that. That is the language of one of the instructional system design called SAM. Critic digital content based on ethical considerations, including copyright laws and the human dimension of representation. That also because you have to follow certain standards, especially taking ethical considerations. So one can learn how to critique a given digital content. Okay, this is one course. Personally, I would strongly suggest that every department can do that, and the students will be quite excited if you offer this right in the first semester, because they're immediately getting into the lab, and possibly some of them are already are familiar with how to record and edit a little bit. So everybody can learn from one another. Then another one, which can be common everywhere, is data management tools for business and education. How do you manage the data? This course provides comprehensive training in using Microsoft Excel and access to solve data-driven problems in professional and academic environments. It covers advanced spreadsheet modeling, data visualization, relational database design, and the interface between spreadsheets and databases for automated reporting. Because this kind of thing will be required in any organization. You don't have to be a specialist in computer engineering or computer science. One may be required to do this continuously. The course outcomes include explain the difference between flat file, that is Excel, and relational access data structures for various situational factors. That doesn't require more than 2-3 lectures to explain what is this flat file with examples can be shown. Construct complex Excel models using advanced functions, logical, lookup, financial to solve engineering and business problems. Analyze large data sets in Excel using pivot tables and Power Query to identify trends and generate summary reports. What this requires is the course need to kind of have large data set examples collected before you start the course, so they can be offered as their exercises. Develop dynamic data visualization dashboards in Excel that meet the human technology interface standards for clarity. Design relational database in Access, ensuring data integrity through proper table normalization and primary foreign keys. Execute SQL-based queries and multi-table reports in Access to retrieve specific information from complex databases. Automate data exchange between Excel and Access to create integrated business or educational management systems. Evaluate data security and ethical privacy considerations when managing student or client records in digital databases. For example, this course is in alignment with PO5, PO10, and PO11 as well. because these courses not only meet the requirements of PO1 to PO5, but they can also address PO6 to PO11 as well. A pure theory course may not be able to that easily address PO6 to PO11. Now, another course that can be common for all is AI skills for professional engineers. So these days, everybody needs to have some knowledge about AI. So one can have a course like this. This course introduces engineers to the practical application of AI tools in their professional workflow. Rather than focusing on training models from scratch, this course focuses on AI literacy and augmentation, using LLMs for coding and documentation, generative AI for conceptual design, and AI driven data analytics for engineering decision making. Again, looking at some of the course outcomes, I'm giving 8 here for every course, but as I said, you don't have to have all the 8. You can be selective in this, make a 5 or 6, whatever you feel like, and focus on that at least initially until you get the all people concerned with that, both faculty and students get a hang of how to go about doing it well. Explain the fundamental architectures of generative AI and LLMs, including the concepts of tokens, parameters, and hallucinations. Apply advanced prompt engineering techniques, a few short chain of thought to generate accurate technical specifications and documentation. Use AI coding assistants, GitHub, Copilot, ChatGPT to write, debug, and optimize scripts for engineering automation. Analyze engineering data sets using AI-powered data analysis tools to identify anomalies and visualize trends. Develop conceptual engineering designs and prototypes using generative AI image and 3D modeling tools. Evaluate the outputs of AI tools for technical accuracy, bias, and hallucinations to ensure engineering safety and reliability. Construct a streamlined engineering workflow that integrates multiple AI tools to solve a complex multi-stage problem. Critique the ethical implications of AI in engineering, including data privacy, intellectual property, and the impact on professional autonomy. Because these are the issues that in the next few years, every engineer has to contend with. So it is better to go through a course of this type. The course is in element PO5, PO7, PO9, and PO11 as well. Another one, an engineer is concerned with workflow automation using AI. This course teaches engineers how to design and implement automated workflows by integrating artificial intelligence with no-code, low-code platforms. Students will learn to connect disparate professional tools like, for example, email databases, CAD, and project management into a self-operating systems that use AI for decision making, data extraction, and task execution. Because in a project, you may have to handle all these type of activities, whatever be the project. So here, explain the principles of robotic process automation and the role of triggers and actions in an automated ecosystem. Identify manual repetitive engineering tasks suitable for automation based on situational factors and resource constraints. Construct automated workflows using platforms like Zapier, Make, or Power Automate to link disparate professional applications. Apply AI agents within a workflow to perform intelligent tasks such as data summarization, sentiment analysis, or categorization. Use AI-driven OCR, optical character recognition, to automate the extraction of data from technical drawings and invoices into databases. Develop an automated technical assistant that monitors project milestones and generates AI summarized status reports for stakeholders. Test and debug automated loops to ensure system reliability and prevent feedback loops or data leakage. Evaluate the security and ethical risks of granting AI autonomous access to professional and personal data streams. Again, this course is in alignment with both with Pivot 5, Pivot 10 and Pivot 11. Let me not repeat this course. Data analytics, another one. This course provides a practical introduction to the data analytics lifecycle. Students will learn to clean, transform, and analyze databases using industry standard tools, Python, Excel, Power BI. The course emphasizes statistical reasoning, predictive modeling, and human technology interface through data storytelling. So, if you have scope for that, you can include data analytics course. And for electronics people, PCB design is one of the something that they need to master by the time they leave the 4-year program. This course provides a hands-on journey through the entire PCB lifecycle. Students move from schematic capture to board layout and final fabrication files. The course emphasizes signal integrity, thermal management, and design for manufacturing constraints, ensuring that students can produce industry standard hardware. Okay, let me not read through all the course outcomes. Okay, we have shown you some examples, but as I said, you don't have to limit yourself to the example courses. You can search the literature or talk to the industry and accordingly modify the courses or create new courses. Basic things you need to follow. Assessment of student performance should only be based on the product produced and not written test. Okay, I think this is the most important one. Please don't convert into a written test. Then the very purpose of SEC will be gone. Suitable rubrics be used for assessment. So when do you consider a project is successfully executed and product is successfully developed? Then for each case, you can develop rubrics. And these rubrics also inform the student how you should produce a good product. That is a part of teaching actually. If you design a good rubric and inform the student this is what you need to follow, you told him how exactly the product needs to be developed. Ideally, SGC should be offered as a 2-credit courses, as I mentioned. The initial attempts to introduce SGCs, they may be offered as 3-credit courses until the faculty get familiar with the dynamics of implementation, because this requires a lot of learning on the part of everyone concerned. Good outputs from SCC can be used as examples in related courses. When you have a large number of students, at least per batch, you are likely to have at least 5-6 very good examples, and they can be used for the theory courses as well. SCCs can be greatly boost motivation and confidence of students and give them a sense of achievement. That's what it is. If these courses are properly distributed, the suggestion is that we have 12 credits for this. Eventually, if you can convert into 1:0:1, you can have 6 skill development courses, or otherwise you can have 4. But these 4 courses distributed, let us say, during the first 6 semesters can vastly improve the motivation and confidence of students, and they really will enjoy the sense of achievement. Okay, so these become an important part of any curricula, because it is required now to include some courses and significantly enhance the employment opportunities of students. And in the next unit, we'll try to understand the design of curricula through examples. Thank you very much for your patience.